Hey there, this is Will Grana, and this is my video demonstration of my CS121 final project. So for my project, I decided to cool my Raspberry Pi by means of mineral oil. So here you can see some Tupperware in which I mounted my Raspberry Pi. Let's see. With screws on the bottom, glued to the bottom to hold it in place, mounted off the bottom to get the best thermal efficiency out of the setup. It has a fan glued to the PCB there that pulls the oil up off the board and off the chip. I also utilized the thermometer that came with the kit to take ambient temperature readings of the bath. And this is the setup for mineral oil cooling my Raspberry Pi. And now I will cut to a screen recording where I can show you some code that I've written for it. So hello again. We are now on my computer connected to the Pi. So first I will showcase this Flask app that I made to monitor the Pi remotely while I'm conducting my thermal tests and gathering data. So this Flask app shows in real time roughly 4 times per second. It updates CPU temperature, core frequency, the core voltage of the chip, the CPU usage of the chip, the RAM usage, and then the ambient temperature, which is using that thermometer that I showed earlier. And so just to show you all how this works, I can run a benchmark of the Pi. And so you'll see that when I start this, you'll see that the CPU usage will go to 100% and it'll show my overclocked frequency. So I'll go ahead and start this now. So now you can see the Flask app working. I'm using 100% of the CPU. Shows the core temperature rising. The core frequency, it's overclocked to 2147 megahertz. At 1.0195 volts, and you can see the ambient temperature also very slowly rising as the Pi heats up the bath. And so we can just wait for this to finish here. It should take roughly 40 seconds from when I started it. So there we go. You can see that now that the task is over, you can see the temperature dropping back down. My CPU usage way down now, just idling. So this is the app that I used to monitor all the tests while they were going on remotely, because many of the tests took hours. And so yeah. This is the website I built to monitor that. So now we can take a look at at the Flask app code. I made this route, this function here, get temp. It gets all of the values that you see up here displayed on the web page, and I used a couple different libraries. GPIO 0 for the CPU temperature, sub-process I needed to get the core clock from the command line. SMBus is for the thermometer, and PSUtil is for the CPU usage and the RAM usage. And so now we can look at the code for the web page. It's called temp.html, and this uses JavaScript to continue to request the information in that from that getTemp function in the app. So this code basically just sends an HTTP GET request over and over again to continue sending the live data into the web page, which is displayed here. So as far as overclocking the Raspberry Pi, the parameters that you need to alter are in the boot directory in a file called config.txt. So if you go down in this file here, you will see here for the overclocking parameters, this ARM frequency will be your core clock in megahertz, which I have currently set to 2147, which apparently is the Raspberry Pi is firmware limited to this. I had plenty of thermal clearance. I know I could have gone much higher, but unfortunately this is as high as I could go. Over voltage here, this is a ratio of voltage. I believe it ranges from -16 to 16. So it's basically just a multiplier for the stock voltage. And here you see the GPU frequency, which I also managed to overclock to 750 megahertz, but since the Pi doesn't really make utilization of the GPU except for when you are using a screen with video playback or playing a game or something, you don't really see any performance improvement on a headless setup with this, especially with the benchmarks that I was doing. It was strictly CPU bound. Only the CPU was doing the processing.